Hey guys, so today we're going to talk about one more way to solve a system of equations. This stuff today is called substitution. This is a good option to use when the system you're trying to solve won't graph very easily. Kind of similar to some of those that we tried a week or so ago, and I showed you how to use your calculator to do them. So I know you're thinking, well, Ms. Potts, if you showed me how to use my calculator, why do I want to do all of this algebra stuff by hand? Well, we've talked about that too, right? The state of Texas is really good about working some problems in that will force you to do it by hand. They kind of work around that calculator piece because they want to know, hey, do you know this method or not? So I want to make sure that you're really comfortable with it. Substitution is really just replacing one thing with another thing. Think about being on the basketball court. The coach will sub players in and out constantly. He'll take one player out and then put a different player in that position's place, right? Same situation, we're just going to do it with algebra. We're going to take one of the variables out and replace it with something that means the same thing. Take a look at this right here, right there. You use substitution to solve a system of equations when one of them is already solved for a variable, or if it would be really simple to solve it for one variable. For example, example 1 right here. This would be a good opportunity to use substitution because x is already solved for right there. It's all by itself, so I can just take the rest of the stuff and plug it in for x and get on with my business. However, over here on this one might not be such a great system to use substitution with because you'd have to do quite a bit of work solving for y or solving for x before you ever got to actually doing substitution. Remember, we're trying to minimize the amount of work that we have to do. This system right here would actually probably be better solved with something called elimination. That's going to be what we talk about in a couple of days. So don't use substitution right here. Let's jump down here and talk real quick about basic substitution. You guys have been doing this stuff right here for quite some time. Basically, right here, I just want you to determine, is A the solution to the system or is B the solution? Well, you guys are really good at plugging stuff in. You know that the first one is x and the second one is y. And you also know that when you plug those numbers in, it has to work for both equations in order for it to be a system or a solution to the system. So watch this. Everywhere I see x, I'm going to plug in the negative 16. And everywhere I see a y, I'm going to plug in the negative 8. So all I'm doing is rewriting the very first system, and I'm using point A as this test point to see if it works. Then I'm going to do the same thing for the second equation and see if A works for that one as well. I'm going to pause and do the work so that you don't have to sit and listen for the whole thing. Okay, voila, there's the work. So what I end up with is negative 16 equals negative 32. My brain knows that that is not a true statement. Therefore, answer choice A must not be the solution to the system. So now I'm going to try the same situation, but I'm going to use answer choice B over here. Okay, so I plugged in this point, and I got negative 8 equals negative 8. So far, so good. But before I can say that this is actually an answer, I'm going to have to go ahead and double check the second equation, 2x minus y equals 0. If that one works as well, then I'm good to go. Okay, so I plugged in negative 8 and negative 16 to the second equation. I ended up with 0 equals 0. This point works for both systems of equations. Therefore, I can say that this is a solution to the system that was given. Let's jump down here now and let's actually solve a system using this whole concept. In this particular system, I'll notice that one of my equations has the y all by itself. There's nothing else on the left-hand side with the y. So what I can do is basically if y is equal to 2, then I come down to my second equation, and everywhere I see a y, I'm going to substitute a 2 in its place. So to solve this system, I would say now I would do the math. What you'll notice has happened here is I went from an equation that had 2 variables that I couldn't solve down to 1 variable which I can solve. And remember, that's the whole point of a system, is getting rid of one of the variables so that I can actually do the math and solve and get the answer I need. Now I'm just going to solve for x by isolating it. So I know that x is equal to negative 3. Way back up here in the original problem, they told me what y was equal to. This is really handy when they do that because it means they've done half of the work for you. Remember, at the end of the day, as long as you have an x and a y, then you have a solution to your system. So over here, our solution is -3, 2. That's the point of intersection for these two lines. And if you'll recall, we can classify each one of our systems based on how many solutions they have. In this particular case, there is one and only one solution, so I would say it's independent. That's it. Let's jump to another example. Here's substitution is going to be another good option for us because look at that first equation. The x is all by itself. Now this one you're going to have to pay attention to because they're not telling me exactly what x is. They're telling me that x is some number plus 2, y plus 2. But it works the exact same way. I'm going to take this quantity right here and take it down to the second equation. And everywhere I see an x, I'm going to plug in y plus 2 because they told me that x is the same as y plus 2 right there. So I can change them out back and forth, kind of like the coach does on the basketball court, right? So everywhere I see an x, I'm going to take it out and put the y plus 2 in its place. I leave the y alone over here in the 3y because I don't know anything about it yet. But look at this red equation. Now I'm down to one variable. There are just y's in this equation, so I can solve this. Use your distributive property, solve for y, and then we'll go back and show you what to do with the rest. So 5y plus 10 with the distributive property. Now it's just a matter of combining like terms. I notice that my y's could go together. Be careful, remember back to the very first couple of days in Algebra 1. We don't need to do the opposite to either one of these to combine them. They're on the same side of the equal sign, so I just need to do the math that says 5y plus 3y is 8y. Bring down all the rest. And now I can't do any more math on the left-hand side, so now I can start doing opposites and solving for the variable. So y equals 2. In the first problem, they had already given me one of the values for one of my variables, so I was done at this point. Unfortunately, in this case, they didn't tell me exactly what x was equal to right back up here. So I'm going to have to take my y value, now that I know that y is equal to 2, I'm going to take that all the way back up here, and I'm going to plug it back into that equation because now I can figure out what x is, since I know what y is. Again, we're just going to substitute one more time. So x is now equal to 2 plus 2, instead of saying y plus 2. So my x value is 4. That makes my final solution 4, 2. It's the place where the two lines intersect, and it's an independent solution because there's only one answer. Let's try one more. Okay, so I plugged that 2x minus 1 into the second equation everywhere I saw a y, because the first equation tells me that y is 2x minus 1. They're the same thing. So I did all of this math in blue and red, and I ended up with x equals a -1. Again, I have to have a point of intersection for my answer, and so I've only got half at this moment. So I'm going to take that -1, and I'm going to plug it back in right there to get the rest of my answer. Once I have an x and a y, then I have my point of intersection. This is an independent solution because there's only one. Don't forget that part. One last problem, you guys, and we're done. This time let's put it in an application context. Back to perimeter because I know you guys love those so very much. but I know you can do them. Perimeter, remember, is just the distance around a figure. Talking about a rectangle in this case, so we know there's 4 sides. They tell us this time that perimeter is 66 meters. You guys already know how to find perimeter. You know that it's 2 times the length and 2 times the width to get the total perimeter, which is 66 in this case. Then they go on right here to tell you a little bit more about what's going on. It says length is 1 meter more than 3 times the width. Go back and listen to that again if you need to. As I wrote and as I read, I was directly translating that sentence from English back to algebra. So one other thing you got to watch out for is that 1 right there. It's easy to confuse as a lowercase l, so make sure you know that that's a 1. Direct translation. Now I have myself a system. Substitution is going to be a great option to solve this system because look at the second equation. L is already solved for. It's all by itself on the left side of the equal sign. So I can simply take this stuff right here, because that's what L is equal to, and I'll plug it into the second equation, or the first rather, everywhere I see an L. Substitute it. So instead of 2 times L, I'll write 2 times 1 plus 3W. Then bring down the rest, the 2W and the 66. Use that distributive property and solve for W. You'll notice it's the only variable left in the equation. Combine your like terms at this point. My equation's getting a lot prettier, and so now I can just solve for y, no, not y, w, by getting that variable all by itself. So the width of our rectangle is equal to 8 meters. Make sure you've answered the question that they asked, which was find the dimensions. In this case, I guess I haven't because I only found one of the lengths. Now I've got to go back and find the other. Take that width now and plug it right back into that length equation. We know that length is 1 plus 3W. And if I know what W is, then I can plug it in and use it. So my length is 1 plus 3 times 8. So my length is going to be 25 meters. Again, make sure you've answered the question. It asks for the dimensions. In this case, I'm good because I have a length and a width now. That's all there is to it. Make sure you go back now and write your questions and write your summary at the end. Remember, for your summary, really what I want you to focus on is to go back and answer the essential questions, which you'll find back up at the top or the beginning of this, this page, beginning of the notes. If you're new to class and you're not real sure what I'm talking about in terms of questions and summary and what this whole Cornell Notes thing is, it would really be great if you would make it some time to come into tutorials before you come to class in the next couple of days, and then I'll show you what it is we're talking about and get you caught up. Hope you guys are having a great weekend.